Okay, so the angle between planes is where we left off, and we were saying that two planes intersect in a line. The angle between two intersecting planes is defined to be the acute angle, not the wide angle, but the smallest angle determined by the normal vectors, okay? So the angle between two planes is defined to be the acute angle determined by their normal vectors. So if I find the normal vector between of one plane and then find the normal vector of the other plane, then all I need is to find the angle between those normal vectors. So this one may have a normal vector as such. And then this other plane may have a normal vector as such. And so I just need to find the angle between the two normal vectors. So this is N1 and this is N2. So an example would be find the angle between the planes. One is 3x minus 6y minus 2j. What am I doing? Minus 2z is equal to 15. And the other plane is 2x plus y minus 2z is equal to 5. So what is the normal vector of the first plane? What's N1? Anaya, Anaya, what's N1? What's the normal vector of the first plane?
You said what's the normal vector of the first plane?
Yes.
Q, move it up some. What do you mean, what's the normal vector?
Okay, so remember when we defined the equation of a plane, the equation of a plane, it required a point and it required a normal vector. So the point we had, the normal vector was ABC. So therefore we had A times X minus X naught plus B times Y minus Y naught plus Z equal to Z minus Z naught is when you dotted those two. But if it was perpendicular, they were equal to 0. So when I give you the equation of a plane, you should be able to pick off the normal vector by the coefficient of X, the coefficient of Y, and the coefficient of Z. Okay, so this plane, the first plane is 3x minus 6y plus 2z. So its normal vector is 3i minus 6j minus 2k. And then N2.
Oh, it's 2i plus j minus 2k.
Very good. Okay, so how do
So
you find
basically
it?
you're just changing the letters.
Well, no. What there's, okay, so so this plane, if X, let's say, so the first plane for a moment, 3x, the first plane has normal vector that you just gave me. And the point on the plane is 5, 0, 0 is on the plane. So from here, I can find the equation of the plane to be 3 times x minus 5 minus 6 times y minus 0 minus 2 times z minus 0 is equal to 0. So that's the equation of the plane. You take the coefficients of the normal vector and then you take the value of the point. And you make that equation, and that gives you the equation of the normal of the plane. So in order to create,
Oh, okay. This was like the homework.
yes, 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 yes. So I'm asking you to go backwards now. I gave you the plane. I want you to tell me the normal vector.
Mm-hmm.
Okay, so I was asking you to go backwards. So now how do you find the angle between two vectors?
You said the angle between two vectors.
Yes, how do you find that?
Don't you do the cross product?
The cross product is going to give you a vector that's perpendicular to both of them.
Oh, okay.
So we're actually going to use the dot product. So
The
if you
dot product.
remember, N1 dot N2 is the length of N1 times the length of N2 times the cosine of the angle between them.
Oh, that's what the homework was. Yeah, I saw that on the homework. I used to practice problems to solve it.
Okay, so so theta is the angle between them. So the angle between the normal vectors is the same as the angle between the planes. So therefore you get the cosine of theta is N1 dot N2 divided by the length of N1 times the length of N2. N1 dot N2, I think I must have done this one before because I have the same answer. N1 dot N2, let's see, N1 dot N2 is 3 times 2, which is 6, minus 6 times 1 plus 4. So we got 4, right? I think I did this one before. The length of N1, I used the same vectors. The length of N1 was, what did I get before? Okay, just figure it out. It's like 30, it's like 9 plus 36 plus 4, 49. So that was 7. And the length of N2, I believe, was 3. So therefore we get the cosine of theta. It's 4 over 21. So theta is the cosine inverse of 4 over 21. And that equaled 1.38 radians. Okay. That's it's almost not quite pi over 2, but it's smaller than pi over 2, but it's bigger. Okay. Here's another type of problem you may have to do. Find a vector parallel to the line of intersection of the planes three x minus 6y minus 2z equals 15, and the same two planes, 2x plus y minus 2z is equal to 5. So we already said when two planes intersect, they intersect in a line. But the one thing that's really cool is the line of intersection. So here's the big deal. The line of intersection is perpendicular to both normals. N1 and N2. So if I just cross those normals, I'll have a vector that's parallel to the line of intersection. So the hint for this is find N1 cross N2. Okay, so N1 cross N2 says draw my line and have I, J, K, 3, -6, -2, 2, 1, -2. So when I do that cross product, I get 14i plus 2j plus 15k. So that vector is parallel to the line of intersection of the planes. Okay. All righty. Next example. Find parametric equations for the line in which the planes, same planes, 3x minus 6y minus 2z is equal to 15, and 2x plus y minus 2z is equal to 5 intersect. So these two planes are intersecting, and when it's like taking your hands and putting them together, and they're going to intersect in a line. So they want you to find the equation of the line. So in order to find the equation of the line, I need a vector and a point. So I already have a point in the direction of the line from the last problem. So we already have a vector in the direction of the line from the last problem. So that vector was 14i plus 2j plus 15k. So now we need a point on the line. Okay. So in order to get a point on the line, we're going to just let z equal 0. So if z equals 0, I get 3x minus 6y is equal to 15, and 2x plus y is equal to 5, because I let z equal 0 in this equation and in this equation. So now these two give me that x is equal to 3 and y is equal to -1. So therefore, a point on that line is 3, -1, 0. Okay, so now I have the vector is 14i plus 2j plus 15k. And they want parametric equations. So therefore, x is going to be 3 plus 14t. Y is going to be -1 plus 2t. And z is equal to 0 plus 15t. So those are parametric equations of the line. Okay, two more things we need to do with planes. All right. The next example. These are tough. We want to find the distance from the point (5, 0, -4) to the line defined with equations x minus 1 is equal to y plus 2 over -2 and z plus 1 over 3. Okay, so I'm trying to find the distance from a point to a line. All right. Okay, so this is how we do it. Distance from a point to a line. Okay, so here is my 3 space. I have a line in 3 space. That's my line in 3 space. And then here's my point. So the shortest distance is right there. Okay. So this is the line L. And L has a direction vector V. So this is the direction vector V. Okay. So L is the line parallel to a vector V. okay? And I'm going to let P naught be a point that is not on the line. I'm going to call it P. So P is a point not on the line. Okay. Then the distance from P to L. So choose a point on the line. So choose a point on the line, call it P naught. So if I choose a point on the line right here, this is my point P naught. So P naught is a point on the line. Okay, so now you can see that I can create another vector called P naught P. Okay. All right, so the distance from P to L, now we have a formula that says the distance from P to L is the length of P naught P times the sine of theta. Okay, so if you take, here's theta. So the distance, this distance over here, which is, this is what we're talking about, the distance, this value right here, that over the length of P naught P will be the sine of theta. So in other words, the distance from P to L over the length of P naught P is equal to the sine of theta. Okay. So now I know from my formula, so recall the length of V cross P naught P is equal to the length of V times the length of P naught P times the sine of theta. So I'm going to solve for this P naught P part, sine theta, and I'm going to put that in. So therefore I get the distance from P to L. In the place of P naught P, I'm going to put the length of V cross P naught P and then divide by the length of V. So that's the distance from a point to a line. So you need the point P naught that you're talking about. I'm sorry, you need the length P that you're trying to find the distance from the line. I need the direction vector V of the line, and I need a point on the line. Okay, so for my example, which I am going to, okay. So the point P here is equal to 5, 0, minus 4. So that's the point P. Now, the vector, if you remember, this is x minus x naught. In the symmetric form, this is x minus x naught over A is equal to y minus y naught over B is equal to z minus z naught over C. Okay? So in the first case, I have x minus x naught. That is the case that says x is always equal to 1. So therefore here, x is equal to 1 plus 0t. Then for the second one, y is equal to -2 minus 2t. And for the third one, z is equal to -1 plus 3t. So that's what those equations are. I'm sorry. I don't know why I wrote 0t. This should be 1t. This is over 1. Okay, so now I know from my parametric equations that my vector v is 1, -2, 3. Okay, here it is. 1, -2, 3. So that's my vector v. And then I know I need a point on the line. So P naught, a point on the line, is the point 1, -2, -1. So now I need to find P naught P. So P naught P says take 5 minus 1, that's 4. Take 0 minus -2, that's 2. And -4 minus -1 is -3. So now I have computed P naught 3, P naught P. So my formula says I need to find V cross P naught P. So let's find V cross P naught P. Well, I need to put it in my trusty little matrix. I, J, K. So V has to come first. 1, -2, 3. And then P naught P is 4, 2, -3. So let me just make sure. V cross P naught P. And I believe this comes out to be -3 minus 12. So I get -15i. And I think that's it. The J and the K are 0. Yes. Okay, so now I need the length of V cross P naught P. That's the absolute value of the length of -15i. So that's 15. And the length of V, where's V? The length of V is the square root of 1 plus 4 plus 9. So that's the square root of 14. Oh, I'm sorry, this is wrong. There's another part to this. I just couldn't see it. I couldn't see it. I think the K is, yeah, the K has a piece. The K is 2 plus 8. Okay, so this is the length of this plus 10K. And that is the square root of 225 plus 100, which is equal to the square root of 325. Okay. I could take the 25 out, but that would leave me 13. So, okay. And then the length of V, we already said was the square root of 14. So therefore the distance between P and the line L turns out to be the square root of 325. Divided by square root of 14. And that's the length. Okay. All right. One last thing. How you doing there, Anaya? Anaya?
Yes, I'm sorry. What did you say? The Wi-Fi is skipping.
I said, how are you doing with this?
It's okay. It's a little harder than the last thing.
Yes, it is. Okay, I have one more thing. This is the distance from a point to a plane. So we did the distance from a point to a line. Now we're going to do the distance from a point to a plane. Okay. So I'm going to draw my plane in the ground. So that's my plane. Okay. And I have a point P, and I want to find the distance from the point P, undo, from this point P down to the plane. So that is what I'm trying to determine. So what I need to do is locate another point on the plane called P naught. So find the point P naught on the plane. So this first point is P, and then I'm going to find a P naught on the plane. And then I am going to create the vector P naught P. And then I need to look at the normal vector to the plane, which we know. So here is the normal vector to the plane. And this is the normal vector. Okay, so now I'm going to look at the angle between these two. I'm going to call it theta. Okay, so now if I take and find the length of P naught P, so find P naught P, then find the length of it. Okay. Well, I can see from here that the distance from the point P to the plane is simply going to be the length of P naught P times the cosine of theta. That's just using a regular trig. Okay. But we've seen that before. Let's recall that if we take that normal and dot it with length, dot it with P naught P, then we get the length of the normal times the length of P naught P times the cosine of theta. So therefore, the length of P naught P times the cosine of theta is just equal to n dot P naught P divided by, and actually we're going to take this in absolute value because we want it to be a length, divided by the length of the normal. Okay. So therefore the distance between the point P and the plane is equal to the length of n dot P naught P divided by the length of n. Okay. So last problem from this section, we are behind. Let's find the distance between the point (3, -1, 4) and the plane which is 2x minus y plus z is equal to 5. Okay, so we need another point on the plane and we need the normal vector to the plane. So the normal vector to the plane is 2, -1, 1. So that's the normal vector to the plane. Now, if I look at this, I can choose any point I want. So I'm going to choose an easy point. So let's let P naught be the 0.005. This is on the plane. So then I need to find P naught P.
Wait, so I have something to say. I'm sorry. I'm sorry
Yes.
it's last minute, but I have a doctor's appointment at 4 o'clock. So do you want me to stay logged in?
Do I want you to stay logged in?
Yes.
No, you need to go?
Yes, at 4.
Okay, then I'm going to stop.
Okay. I'm
I'll
sorry
stop.
that we're really behind. Is it a
Okay.
lot that we can't catch up on?
Oh, we'll catch up. We'll catch up.
Okay. I'm sorry about that.
That's okay. All right.
Thank
Thank
you. I'll
you.
see you tomorrow.
All right then. Bye-bye.